Hello everyone, good evening and thank you for joining us. We have Runcy here from GDG Cloud Bangalore. Welcome sir, and he's 10 times multi-cloud certified. It's so good to have you here with us. He's a technophile, he's a
Thank you for
data
having
privacy
me.
enthusiast, and he's also a computer polyglot. Please go ahead, sir. Over to you.
All right. Thank you so much, Karthik. I hope you can see my screen, Karthik.
Yes, sir.
Yeah. Okay. Cool. So let's get started. All right. Pleasure to be here with the PES folks, and thank you, Karthik, for the invitation. Let's get started with the GCP and Cloud 101 in general. So when Karthik extended me this invite, and I was sort of like in a dilemma: should I start with just a GCP specific stuff, or should I just give like an overview of cloud in general? And I thought, let's just mix and match the whole thing and then probably walk through the whole cloud with taking the GCP in the stride. Okay. This is sort of like my promise for the next 45 minutes or whatever time that we have. And we're going to get started by giving like a generic intro and an overview of the cloud, right? And then talk about the different specific or the aspects that actually makes the cloud computing, right? And introduction to GCP, obviously, without that, it's not complete. So I'm going to stitch the second part of it with the respect to the GCP, and then specifically about the resources for learning GCP and the cloud in general. As I said, it's also going to be like a cloud touch up, right? And then the various training and certifications that are there for the cloud, and what sort of like the next model that is being evolved in terms of the cloud computing, right? And finally end it off with some sort of like a general guidance as students, for how to build like a career in tech, not specifically in cloud, but generally in tech in the detail, but it's coming from my personal experience, right? Before that, like a brief introduction about me. I am working as a principal software engineer at Ronicol. I've got some years of experience with me. I've got a couple of cloud certifications as well in all the major providers. In also have a patent in cloud security, and with a primary focus on serverless and containers. So that's sort of like I am firm believer of that particular technology, and also see the future in terms of a multi-hybrid cloud, right? In addition to this, I also organize meetups like the GDG Cloud Bangalore, the AWS user group, and the Cloud Native. Also, we speak at regular conferences and have won a bunch of hackathons multiple times, and also been recognized by Google as sort of like a community influencer. All right, so enough about that. Let's get the ball rolling with what the cloud computing is, right? And this is sort of like a thing that I've just took from the Wikipedia, and all of you can read. And I'm not going to repeat what it's being written, right? But just look at the things that's been underlined, right? So cloud computing is generally you get the resources, and this resources could be, especially when we talk about cloud, it's mostly the data and also the computing power, right? That's been associated at the push of a button. So it's available on demand, right? So you do not actively manage those resources. It is just procured by you by some sort of like a API or something, and it is available to many users. So this traditional concept of the data center, that is still there, but it doesn't belong to one entity, but sort of like a shared tenancy, right? So me and you and everyone can get access to that common pool of resources at the push of a button, which is managed by someone like a Google Cloud or an AWS or an Azure or some. So that exactly is cloud computing in a nutshell, right? So with that context, right? So there is this misconception that there is just no cloud; it's just someone else's computer, and that computer are mostly Linux servers, right? Yes, there are Windows and ARMs and all the other things, but it's mostly when we talk about cloud, we are using somebody else's computer, which is mostly sort of like a Linux server, right? So what does this actually mean? So it means that the whole picture that you can see is sort of like a data center, right? Now in traditional, like before the cloud computing, right? Maybe like 2007, right? When AWS launched the cloud, so to speak, right? There used to be these data centers in almost all the major companies, right? And even if like you had a startup, you need to have like a server room. Now that is sort of like a distant memory. You need not invest in this huge amount of things that's required to build up a massive server room. Instead, you can use the servers that's just available on the cloud. So that actually means you do not have like a heavy lifting to do to get your company up and running. You do not need to manage your servers and everything. And that is precisely what it means, that the infrastructure and the thing has gone a paradigm shift. Because from zero infrastructure within this room, I can do a startup, right? So that's how flexible it is with this cloud computing. And with that, there's a whole lot of security aspects to it. And when I joined the industry, this is sort of like the network architecture diagram that the IT person at that company gave to me, right? The big bad world of internet sitting behind a firewall, which is letting only the good traffic go into the glass house being the enterprise, right? And all the bad actors are just vector heavy. But from this traditional view, because of the cloud computing, this is sort of like the modern view. The glass house is still there, but everything that you see around, right? Like the SaaS, software as a service, PaaS, platform as a service, FaaS, functions as a service, infrastructure as a service, right? Container as a service, desktop as a service, right? Yeah, exactly. You can spin up a whole desktop over there. So you can, your thin client can actually be there. You not have even have like an operating system. So now everything is there upon the cloud. And if that, so this is sort of like the paradigm shift that we are actually talking about in terms of the cloud computing, right? So with that, let's just understand what are the important facets that makes the cloud, right? It is ubiquitous, which means the cloud is everywhere. You can actually reach it from even with your 4G hotspot, right? So you need not have like a distance. So now I've been working from home for the last 7 months, right? Ever since March, so before the lockdown, right? Maybe even like the first week of March. And I've been entirely working on cloud computing with just my internet connection. So the world is sort of like the distance is gone glow. The very fact that I'm giving you this lecture sitting from here is the very fact of the usage of the cloud computing, right? So the cloud is everywhere. It is just there. It is infinitely scalable, right? With a push of a button, you can actually add multiple features without even breaking like a sweat. It is deeply integrated. So unlike the traditional ones, it is definitely integrated deeply into the network and the fabric of what you use. And it is comprehensive because it is scanning every byte that actually goes into the network. And it is intelligent enough, because I'm not sure if you folks would remember, but when AWS started probably way back in 2007, right, there were like hardly 3 or 4 services. Now if you go into the AWS console, you actually need like a scroll bar to see the list of services, right? So that's sort of like the intelligence that we have actually talked about, right? Even in with terms of GCP, it's like huge. I mean, the amount of services that's been getting launched in Google Cloud as compared to the previous ones, it's just mind blowing, right? So that's sort of like the intelligence that we actually talk about. So with that context, I would like to encourage everybody to sign up for the GCP free tier, and bear in mind that you actually need like a credit card. So as like a sort of like a student, it would be a little difficult, but you would be charged, I think, about uh, 25 or 50 Singapore dollars or something, which would again be refunded back or something. I think it's much less, I guess. So anyway, if you sign up, you get about $300 of free credit. This you can use to build your prototype. You can use it for any service that you want, but don't use it for Bitcoin mining or anything else, okay? So because otherwise you would be red flagged and you'll be kicked out of the platform. But you could use that to just do and play around with whatever you want. And you also get, in addition, after this $300, a 20 plus free products that you can actually use up to a certain monthly free tier. And that is basically mentioned in the fine print. So what exactly do you get in this free tier, right? So you get a compute instance, you get about 5 GB of storage that you can actually use cumulatively per month, right? And cloud functions, and I will come back to what cloud functions are. It is sort of like the serverless offering. So as you can see, I'm tying up the cloud concepts with the GCP concepts to give you like a rundown of both, right? And then the cloud run, which is sort of like the containerized managed container workloads, right? And I'll talk about containerization as well in the upcoming sessions. And GCP is known for its big data, AI and ML. I mean, let's all face it, Google has all of our data, right? And it obviously would not be like a surprise if the Google's algorithms for AI and machine learning is the best, right? So there is like a lot of emphasis on the machine learning and the AI stuff, and Google is definitely the king of the hill over there. So there is like BigQuery, there is Vision AI for your computer vision. Check out the natural language API for your NLP projects and speech to text. So again, these are like very limited subset within your free tier. As I said, there are like 20 plus free tier products that you actually get even after this your $300. But $300 can actually be used for anything and everything that the GCP offers, right? So I don't want to like fill up this whole thing, but this is sort of like the prominent ones that the GCP there. So with that, context, I want to dive deep into each of the major subsets that actually makes the cloud computing. So the first one is basically the compute. When you actually talk about cloud, it is basically the compute that is basically in everyone's mind. Like as I said, you are using someone else's computer, which is mostly a Linux workload, right? So what exactly is the compute aspect? Obviously, there is the GCP perspective, the compute engine, that's a service that is being offered where you can actually spin up your virtual machines or your GPUs or TPUs, right? Now, what exactly are TPUs? TPUs or tensor processing units are sort of like a specialized CPU thing where it is more optimized for your tensor flow framework, right? So this is sort of like the compute engine aspects, which is specifically provided for the GCP, right? So TPU is only available in the GCP part. And then there is the app engine. So this is sort of like where you use the platform as a service. You remember I've talked about the PaaS, right? So this is the platform as a service. Now, how is this platform as a service different from the compute engine, right? So because in the platform as a service, you actually have the CPU, but on top of that, you get to pick and choose. They have like a predefined set of the workloads, right? Say, for example, you want to run a Tomcat server or like a Python application, right? Or you want to get your Java applications quick. So you go to the GCP console, you pick the app engine, say that I have this Java application that I want to run. It will spin up the CPU and all the associated JDK and the JRE and all the associated things so that you don't end up spending time installing those things. So those dependencies get auto installed. So you have this whole platform that you are ready to go. So that's a platform as a service, right? And the GKE or the Kubernetes. Now, all of you or some of you would have heard about Kubernetes. So Kubernetes is basically the orchestration for the containers. Now, what exactly are containers? I'll come to that later. But this is the managed Kubernetes offering or the Google Kubernetes engine or the GKE as it is being called, right? And Google was the one who came up with the Kubernetes. They have now outsourced it or sort of like donated it to the CNCF project, that is the Cloud Native Computing Framework, right? So that's now sort of like an open thing, open source project that continues to be there. Google no longer owns it, but it is born out of Google. And then the cloud functions. So cloud functions is the serverless offering from the GCP. And what exactly is serverless? I again come to that, but this is the offering that is it. So the next few slides, I'm going to set the context on what exactly are containers, serverless, and then sort of like a little bit about the orchestration or the Kubernetes part, right? So what is the difference, right? Now, if you look at the one on the left side, that is a VM, you would have some sort of like a hypervisor, right? Hypervisor is sort of like the layer that basically tests the virtualization for you if you spin up a VM. So if you have like a Windows or a Apple book, right? Apple MacBook, right? What you do is you install something like a VMware or a Oracle VirtualBox or something, right? And you can spin up any number of instances. So now that Oracle VirtualBox or VMware is your hypervisor, and that basically helps you spin up multiple instances to help, which are the guest operating system, and on top of that, you build your applications. Now, how is it different for a container? Now here, the again the operating system or the host operating system is still there, But instead of that, there is something called a container daemon. Now, I don't want to dive deep into what it is, but yeah, think of it as like Docker. Okay, so you have Docker, and there are other offerings like Rocket OS and Core OS and all the other offerings that are there. And on using Docker, you again build your applications with just that. So you can see that this layer of the stack on the right is much leaner. It is directly interacting with the host operating system because the hypervisor is not there, and hence it is more faster, leaner, and better, right? So that's sort of like the container part. So this is sort of like the easy to thing analogy, right? In the VM, you would have like a huge amount of compute resources. And when I say compute resources, it could be memory, storage, networking, and compute, right? So you can have like two CPU instances with like about 5 GB of RAM, and then all amount 100 GB of hard disk for your VM. But your application that is actually running could be a small one, right? And all the other resources is just wasted out. But in a container, you spin up resources only for that particular application. So if your application needs only about 128 MB of memory, your the container daemon just allocates only to that particular thing. It only gives you that particular amount of hard disk or whatever, or that persistent storage that is there, right? So that's the fundamental difference between a VM and a container. So it's much leaner, it's much more easy to scale out. Now, what exactly is scale out and scale up? I'll also talk about that, right? And what exactly is now serverless? So that was sort of like a one-on-one with the containers and everything. And Kubernetes is basically the one which manages the whole part in the container ecosystem. It's sort of like the orchestration part. There's also Docker Swarm and a couple of other things, right? I don't want to dive deep in it because this is sort of like a cloud 101 session. And what exactly is serverless, right? So serverless is again a layer of abstraction on top of containers, right? In the containers, you still had to manage your host operating system, right? Because, for example, if your server ran out of the amount of total space that was available, then you had to manually bring up the other node and then hook it up so that it becomes a cluster, and then your containers can then scale. But with serverless, that thing is also completely abstracted. So you build your applications without actually thinking about serverless. So this misconception that there are actually servers involved in the serverless, right? It's just less servers, right? So just for kicks, I've put, the main providers like the AWS Lambda, the Google Cloud Functions, and the Azure Functions, right? So these are the major three offerings from the serverless thing. And I'm sure all of you would have heard about Lambda because the serverless concept started with the AWS Lambda, yeah, I think in 2014. So what does it actually do? So the serverless is basically a layer of abstraction where you actually build the stuff without any operation. So this concept called no ops, right, is gaining popularity. So that is attained with serverless. It helps you scale out. And now I'll come to what the scale out and scale up is, right? So there are two parts. There is the vertical scaling and horizontal scaling, right? Now, what exactly is the horizontal scaling? Horizontal scaling means you have a certain node of servers that are available, right? With say about 10 GB RAM and 1 TB hard disk or something. With horizontal scaling, you add another server of the same instance, right? So one server, two server, three server, identical. With vertical scaling, you have the server, but it's running out of space. So what you do is you increase the RAM, you increase the CPU, you increase the processor, and that is vertical scaling, right? So when you hear these terms, this is what it actually is. The horizontal scaling is n plus one, n plus two, three, four, whatever. The other one is just the increasing, 2x, 3x, 4x, the increasing of that, okay? So yeah, sorry to diverge about that, but coming back to serverless, this is sort of like the event-driven model, right? If the waits for certain events to be kicked in and just helps you get the ball rolling in terms to that. So what is the evolution, or how did we actually get here? Because on the bottom left, when it all started, it was started as the bare metal, right? And you can see that the x-axis, that is there's like a decreasing concern and control for the management. So it is definitely more on the left side. And as you go up on the y-axis, there is an increasing focus on the business logic. So you think less about servers and your management with respect to the serverless functions that is a top right, right? So it started with bare metal, then it became the VMs that I've talked about, right? Then came the containers, right? And now we have the serverless or the functions. So we think all in terms of microservices. So these are something called as a microservices, which are obtained with the container model or the serverless with the functions model or the FAS, functions as a service. Or the containers, it's called the CAS, the container as a service, the slides that I've talked about earlier, right? So this is some sort of like a funny thing that I actually wanted to put, because you might be asking like, are we fixing things that doesn't really exist? No. Well, it's definitely think of serverless as sort of like a cashless, right? Cashless doesn't mean that there is there is no cash. It just is less cash. So serverless is also less servers, right? So the similar analogy, right? So there are definitely different things, and it is very safe to say that the serverless is definitely eating the stack, right? And when I say the stack, the whole stack, I mean in terms of the bare metal stuff, the whole thing, right? So serverless, you just think about the business logic. Okay, so another common misconception that the people would give you and hear with a lot of terminology is the serverless and the FAS, or the functions as a service, right? So serverless is this whole idea. Serverless does not mean that it is only about functions. Say, for example, all of you would be using AWS S3 or the Google Cloud Storage or Google Drive or whatever, right, to put your stuff. You just go there and then just put it, right? You don't worry about managing your stuff, right? If you spin up a Google Cloud bucket or something, or the AWS S3. AWS S3 is serverless, because are you managing those servers? No, right? It's just you open up your S3 bucket or your Dropbox or whatever, and you just put it. Now the Dropbox and everything is sort of like a more packaged thing. It's sort of like a pass offering. But when you do something on your cloud computing stuff like AWS S3, that exactly is serverless. You manage your databases, which are just managed by you. That is serverless, right? But FAS is basically the small pieces of code that you actually write in terms of microservices, whether it could be in Python, C++, Golang, Java, or whatever, right? And you hook it up to trigger the events. That is FAS, or the functions as a service. So this is the distinction, and I want you to take this home, that serverless is this whole umbrella, and FAS is a small subset of it. And this is that analogy that I wanted to drive home, right? So with that uh, background of the compute aspects, I want to dive deep into what are the cloud databases aspect, right? And in terms of the database capabilities, there are obviously the relational and the non-relational, and then the whole petabyte scale and all the other stuff, right? So the cloud SQL from GCP is sort of like the managed MySQL and the Postgres and the traditional MS SQL offerings that is there. So if you go to a GCP and spin up a Cloud SQL, it will ask you what sort of like a database that you want. And if you want like a traditional relational database, this is what you actually want. So if you want to run your MySQL server without bothering about how it's actually done, you use the Cloud SQL. Cloud big table, right? This is now the big boy, right? If your data is like huge, and when I say huge, petabyte scale, right? And if you want some sort of like a low latency, this is sort of like a secret gem from the GCP stable, right? It's highly non-relational data, and it is like super fast. It helps you build up. And then the Firestore, right? So it's sort of like a document DB. All of you would have heard about MongoDB, right? So this is sort of like the equivalent offering from the GCP, where you help you build the NoSQL document style database, right? And Cloud Spanner. So this is where the relational database that is horizontally scalable. See, horizontally scalable. That means it will spin up n number of instances depending upon your need automatically, instead of vertical scaling. If your query is basically taking like a huge number of compute resources, it will spin up an additional cluster all transparently to you and does this. So it is horizontally scalable, and that's the thing that you want to remember, right? So with that, not talk about GCP is complete without any mention about the data and analytics capabilities, because it's sort of like the number one go-to cloud in terms of data and analytics. right? So this is where the secret gem of GCP, that is the BigQuery, and it is basically used for data warehouse. Again, BigQuery is serverless. So because you do not worry about managing your stuff, you just dump in the data, and when you run that query with the SQL style commands, it will spin up the instances that it runs. It will spin up the memory that you want to do, and it would have automatically offered what sort of indexing it needs to done with the data model that is being provided, and gets you that results in a very uh, fast manner. So this sort of like the BigQuery offering, the database warehousing capability. And if you want to do some sort of like a data processing that is like a stream level, now what exactly is stream? Stream data is some sort of like the data that is coming in a constant speed. So as you can see, I'm building the cloud concepts with the GCP. So say for example, the IoT devices, right? You have the edge computing, right? So edge computing is say where the processing happens at the edge, and then that sort of like a minimal process data is then sent over to the cloud for the huge processing. So if you have this sort of like a huge data that is coming in some sort of like a POS machine or point of sale machines, right? Or the remote sensors that are just deployed across the oceans or whatever, right? So those are IoT devices, and cloud data flow is sort of like the managed offering in terms of GCP to do that, and it for high velocity, right? And the cloud composer. Now, what exactly is the cloud composer? So you have this data that is coming in, but now once the data is reached, you want to do some sort of like a business logic to it. That is, if it is this data, I want it to transform and massage it a little bit and then add the business logic and put it into that table, right? If it is this data with very minimal subset and very less, just discard it, right? And if this is other one, just do some sort of like another processing and just it's for long-term archival and just put it in the storage thing, right? So this is where the cloud composer or the managed workflow comes to the picture, right? And that's a managed offering. Uh, this is something called as the ETL framework, or the extract, transform, and load sort of a workflow, right? And the Cloud Composer is the one for it from terms of GCP parlance. Now, what is data prop? Now, if you are in the data background, you would have heard about the traditional Spark and Hadoop, right? The whole big data sort of like came into the picture with this whole Hadoop. And data prop is sort of like the managed offering from the GCP if you want if you don't want you to manage your Hadoop and Spark cluster. And trust me, it's not an easy job, right? So you use cloud data proc for that sort of a thing. So with that, now let's just dive into the networking. And yeah, one word of thing, I've just picked the main important providers, and I don't want to fill up the slides. I don't want to put a lot of logos into it. So I've just picked and choose the 4 or 5 important services that are there. If you look into the GCP, so this doesn't mean that the GCP only has those services. No, GCP is huge in terms of the collection, right? So I encourage you to go and then check out the console and then see what are the other ones. These are the important ones that I've picked for this 101 session, right? So now let's just go into the networking aspect. And again, it all starts with the CDN, or the content delivery network, right? So what exactly is a content delivery, right? So you are sitting in India, you are accessing the servers like Facebook, Instagram, and all other servers like Gmail and everything, right? Now, the servers could be anywhere in the world. But then, what a cloud distribution network, or if you want to watch the videos on Netflix, right? The streaming is quite fast, right? How you do it? Because there is like a pre-processed set of data that is already there in the server that is closest to you. So when you hit Netflix or Facebook, your photos that you actually see is actually coming from a server that is very close to you, instead of the main servers or the data centers that could be sitting in, I think the Facebook data center is somewhere in Sweden. It is in the Arctic. So instead of that, because they can save a ton of money in air conditioning. So instead of coming from the Arctic Circle, your data could actually be coming from a server that is closest to you, right? And that is the cloud delivery network. If you have heard of this company called Akamai, so Akamai Technologies is basically the CDN part. That actually does this. Cloud CDN is the offering from the GCP, right? And now the cloud load balance. Now, what exactly is a load balancer? It's very simple as this diagram says, right? You have multiple servers sitting behind a common endpoint, which will basically distribute the traffic. And how it distributes the traffic, it could be the various algorithms. It could be like a simple round robin logic, right? I hit one, the second request goes to the other one, right? It could be a load balanced one. I mean, it weighted traffic. That is, if the server one is having a high load, then obviously the load would go into the server two. It could be latency based rules, right? So if the user is closest to that server, it will hit that. Otherwise, it will go into the. So this cloud load balancing is the managed service from GCP that does the load balancing for you, right? And it does multi-region and all the other stuff, right? So what exactly is this region, right? That's like a good point. So in cloud parlance, there is this region and then there is this zone, right? So what exactly is a region? A region is a geographical entity. That is when you say that Asia Pacific region, right? So it means that the GCP has a region presence in Mumbai or Singapore or Korea or Japan. That's the Asia Pacific region. So you go into the Google Cloud and you select a region. So it could be from any of these. Now, you can be specific. I want my server to be in Mumbai because of the data regulations or something, or I want my servers to for the European customers to reside in Europe because of the EU data protection regulations. So that's the region. What exactly is the availability zone? Availability zones are nothing but the whole data center. So within a region in Mumbai, so there could be like multiple availability zones. So if you actually do like you nuke the whole data center, your data would still be available or served from the other thing, right? So the GCP or the AWS would have multiple availability zones in Mumbai, right? So there could be one in Mumbai, it could be in Navy Mumbai, or it could be Pune, right? There is like certain number of certain amount of distance that has to be there between the data centers. So that's the availability zone, right? So, what exactly is Cloud Armor? Now, Cloud Armor is sort of like the security aspect from it, right? Now, the DDoS attack or the distributed denial of service attack, right? So, in the cloud, when you do something, you are susceptible to be taken down by the bad actors, so to speak, right? So, the distributed denial of service is basically where you actually overwhelm the server with a huge, enormous amount of traffic, so a server becomes genuinely unresponsive and is not able to serve the request. So there are managed offerings in terms of the Cloud Armor, which helps you give the DDoS protection and also helps you set the web application firewall or the WAF, right? So this is all of you would have heard about the OSI model or the Open Systems Interconnect, that is the L1 to L7, right? So the WAF is the one which is working in the layer 7, right? So if you are basically in HTTP or HTTPS or whatever, you want to provide protection, so you deploy a WAF or a web application. And Cloud Armor is the go-to service for that. DNS. So this is the DNS offering, and DNS is nothing but one which converts your host name to IP addresses. So this is the aspect with respect to that. So with that, I want to touch into the security aspects of the cloud, and I want to map it to the GCP products and also talk about the cloud security engine. And it all starts with the IAM. So it basically gives you permission on who is the identity for you to access, and then provides a fine-grained permissions of what are the responsibilities and uh, delegations that you can actually give to the users if you have access. So that is the identity access manager. That is a cloud IAM, the offering from the GCP. But in terms of the security, it's basically comes down to authentication and authorization, right? Or if you call it as the A and A in the cloud, right? So what exactly is authentication? Authentication is I am who I am. Am I Runcy or something, right? So do I have something that proves that I am Runcy? Now, authorization is something. Does Runcy have this permission to do these things? So that's the authorization. So authentication and authorization. And IAM is sort of like the backbone which does that. Now comes the KMS or the key management system, right? So now I'm not sure if you know the private encryption and I mean and public encryption and private key and private key and public key and symmetric encryption and asymmetric encryption, right? But it is basically a large amount of huge prime numbers that are actually involved for deciding these things, and it helps create a key, and that is your private key and your public key, right? So this key has to be managed and also have to be accessed by all of your applications that have the proper access. So Cloud KMS is sort of like the managed service that helps you set the basic context in terms of managing your keys without you providing a bunch of, right? It's a secure man. Shielded VMs, right? Now we talked about the compute or the GCP compute aspect. Shielded VMs helps you create the VMs which are more secure, right? So it is more hardened. Now, what exactly is a hardened VM? A hardened VM is making sure that when you spin up a VM, you do not expose the ports. You are making sure that your capabilities in terms of locking down the system, making sure that the IP addresses are not exposed, the ports are basically locked down, you have the proper ACL or the access control list. All of these are provided to make sure that the kernel is basically hardened. You are not vulnerable to any of your data. And that's the shielded VMs that is there in terms of a managed offering. So you can spin up, instead of a VM, you can spin up a shielded VM, which is secure by default. And then the cloud secure scan. So we talked about the app engine earlier. So that's sort of like your PaaS offering. Now the security scanner is sort of like a reference that you can actually use to make sure that the apps that you actually deploy on your cloud app engine is secure or not, or if there are any vulnerabilities that are actually there. So these are the important ones. Bear in mind, this is nowhere complete. There are like other set of maybe about dozen more security services from the GCP, but these are the important ones that I want to picture, right? So with that, I want to emphasize more on the security aspect, and I've made this slide especially for you because this is sort of like the shared responsibility model that is in the cloud, not specific to GCP or AWS or Azure or Oracle Cloud or anything. This is the shared responsibility irrespective of whichever cloud you use. Now, the security in the cloud, there are basically two aspects. There is security of the cloud and security in the cloud, right? So what does it actually mean? So you have this data center, right? I've talked about regions and availability zones and everything. Availability zones are nothing but your data center. Whatever you use is in the cloud is sitting in a data center, right? So the security of the cloud, that is the physical security, making sure that the uh, premise is basically safe. No unauthorized person has access to the data, right? Making sure that the cables that are used inside the data center do not allow eavesdropping. That is, a Cat6 cables are basically used, right? Making sure that the perimeter security is safe. That is security of the cloud, and that is the cloud vendor's responsibility. Now, what exactly is security? You bring up a VM or you spin up a VM, this thing, a cloud function, right? And but you have like the least amount of security, right? You have your ports open. You do not have your proper operating system standards, right? You do not enforce any identity or best practices, right? And if you get a data breach and if your application is exposed, the provider has no responsibility for it because you did not bring up the uh, application in the proper manner, and that is security in the cloud. So there are two aspects, and this is very important. So if you have a data breach and if your data is exposed and if the fault lies in you having a very bad encryption or a very bad security practice, the cloud provider cannot be held responsible. And this is the shared responsibility. That is, the security in the cloud is shared between the customer, that is you as a user, and then the provider, right? And this is very important if you migrate your workloads into cloud. So if whatever I've mentioned so far has not been overwhelming, look at this, right? So if you can just Google for Google Cloud in 4 words, and these are the various offerings that are there from Google Cloud, all explained in 4 words. and this is very up to date. It is, I mean, the latest revision that I have here is the April revision, and then they keep updating it whenever there's like an event or whenever there's like a major services that are getting launched. And I've pick and choose the important ones from this. Right now, I have multiple ones were not covered, but I leave that to you to go further, and then depending on how you want it to be there. So just Google Cloud in 4 words, and you will just bring up this, and this is the URL for it, right? And I'll share the slides with Karthik so that it can be just given out, or maybe I'll just tweet it, right? So what with that, I want to just shift the gear a little bit and then dive into the certifications that are there, which is mostly talked about. And here the Google Cloud or the GCP certifications are basically 3 tiers. There's the foundation layer where you mostly talk about the associate cloud or the Google Cloud certified for G Suites and everything. And then there is the architect. There's just one certification for it. And then there are like a lot of specialization certificates in terms of DevOps, security, networking, developer, and then the hybrid offerings, that is sort of like the Google Anthos platform. And I haven't covered what Anthos is because I thought it was not a one-on-one thing. So these are the various certifications that are available from the Google Cloud. Now, there's like a lot of bad things, and this is the word of caution that I want to give. Don't go with that Pokemon attitude, right? It's cloud certifications is not playing this game, right? It is not about catching everything and then getting. Now this is coming from a person who is 10x certified. Right now you may be thinking, why am I saying this? Because I am saying this to the student community. From a student perspective, a certification is absolutely no value, because everyone would know that you would have passed the certifications with zero knowledge and just understanding how to crack the multiple choice questions, because that's the loophole that anybody can exploit, right? And that is precisely why I've put this slide, that it's the knowledge is having the right answer, right? You can crack any number of exams by having what to choose, but intelligence is asking the right question. And so I discourage especially the student community to not chase certifications, but chase the knowledge, which can basically ask and come in your way, right? Because certifications as a student with zero experience will not help you anywhere. As a professional, it's a different story because you have the experience to back it up. But as a student, it I wouldn't recommend it, and hence I discourage everybody to play this Pokemon Go. And there's this huge bonus that is there with this respect to the Google Cloud certifications, especially because you get a swag and everything whenever you pass. And I've got a bunch of them, but it's, trust me, it's not that. The certifications come or become useful at a later point of time, but right now it's mostly about the knowledge and the associated skill sets that you develop by building your fundamentals, right? And I'm going to talk about that later in the next few slides, right? So with that disclaimer, I wouldn't discourage everybody from learning GCP. You should definitely learn GCP or cloud in general, but don't learn GCP for certifications, right? So a great insight into learning GCP is obviously the official exam guide, which will basically give you the list of things that you actually want to learn. And you can practice with quick labs. And I know Karthik mentioned about the 30 days of GCP and then the access to the quick labs. Yes, you definitely get that. And there are definitely a promos available and credits. And if you're not familiar with a good aggregator of credits, that is by Sadish Vijay, you just hit this Medium URL, and he does a pretty decent job of up to date of what the available credits are. So you get a number of credits for free, which helps you practice even after this 30 days of GCP, right? So do check it out. Excuse me. Now, the other one is basically the video tutorials that are available from Coursera. This is sort of like my number one recommendations, because this is the official guide, so to speak, from the GCP if you want to learn the Google Cloud. So do check it out from the Coursera ones, right? Another important one is the courses that are available from A Cloud Guru and Linux Academy. And I know A Cloud Guru just recently acquired the Linux Academy, so they've got a great amount of tutorials, especially if you're looking for someone who is looking at the security or the networking aspects, and if you are some sort of like person who want to learn more about it, so do check it out in terms of that. And the other ones are two popular YouTube channels that are there. One is the Learn GCP with Mahesh, and the Awesome GCP from Sadish BJ. So these two folks, I know them personally. They make great videos about GCP, and it's very helpful to get your ground up and running from in terms of the GCP various production services. All right. So with that, I want to move into the second last aspect of this talk, and that is what next, right? And you've got heard of what this thing called as a multi-cloud and hybrid cloud, and what exactly is it, right? So that's sort of like the new thing that's coming up. And instead of focusing on one specific cloud, companies are actually moving into this multi-cloud model where they would have the best of the things, right? For example, AWS is sort of like the number one in terms of serverless, right? But GCP is the best in terms of the Kubernetes or the GKE, right? Or in terms of running your data and machine learning and all of the other stuff, right? So that is because it has the best machine learning algorithms that are there for available to be used. So if a company wants to leverage the best in terms of the serverless to use the some sort of like a machine learning, so they would have a mixed workload. Say for example, big companies like Netflix, they are using AWS and GCP, right? And there are some companies which have regulatory compliance, right? For example, I don't know, there is this think that AWS is Amazon, right? So obviously, AWS is a spin-off from the Amazon, which is into retail. So if you are a retail company, you cannot run your workload on AWS. You have to go for either Azure or GCP. So if the big companies like Walmart or Target or something, right, they cannot have their workloads on AWS. So they entirely rely on the competitors. So this is the retail guys, right? Because Amazon is into retail. So that's the thing. So the multi-hybrid cloud is sort of like a mix of the multi-cloud aspects, and then the hybrid cloud is nothing but your traditional data center, which is the companies have invested millions of dollars in building up that infrastructure. So, and they don't want to discourage all of that. And they use the cloud as sort of like an expansion model. So you build your MVP or a POC in-house, and when you go and deploy it, you build it out in the sky, right? So for example, my company, Sonicol, right? My whole development environment and everything is entirely used in the company servers, but when we deploy it on AWS, right? And AWS is our preferred vendor from Sonical, because every companies would have multiple ones. So we deploy that on cloud. So that's sort of like the hybrid approach. And another sort of like a hybrid approach is where you have your, because of the data compliance and data privacy aspects, your sensitive workload will remain in-house in your data center, but your scale out things would be there on the cloud, because the company management wouldn't want to invest so much of a money in buying out new servers. So if there is like a scale out, or if there's like a huge hit, then the data automatically scales out and takes the volume from the cloud in terms of it. So there is this multi-cloud, which is like combining multiple things, and then the multi-hybrid cloud, which is a mix of the various things. So this is the two terminologies that's actually come up with, right? So the in summary, I just want to just take this home with you, that don't learn the cloud, but understand the computer science fundamentals, right? Because ultimately it's not the technology, it all comes to the CS fundamentals, right? And in cloud, when you say end of the day, majority of them are Linux workloads in a traditional x86 or an x64 architecture. And yeah, there is AMD and Windows and all their things. Most of the cloud, it's basically someone else's computer, which is mostly Linux, right? And think of cloud as sort of like a physical entity. Yes, because it's sort of like a server. Cloud is nothing but a server, but you access it with an API endpoint, and that is the cloud, right? AWS, GCP, and Azure, they are not cloud, but they are services that are defined by a public API, right? So they are services which you can access it. And always think the cloud in terms of building blocks of compute, storage, memory, and networking. That's the building block of x86 or x64 architecture. That is the backbone. So anytime when you say cloud or your workload, it is nothing but these four aspects and the various names for each of these, right? In terms of compute, you have the GCP compute, which is equivalent in AWS EC2, right? You have the cloud storage, which is for storing of the stuff. In AWS, it is the S3 or the Azure Blob, right? You have the various databases in terms of NoSQL, like the Firestore we talked about, right? DynamoDB. They are the NoSQL, but end of the day, these are just various implementations that run on compute storage, memory, and network, right? So I know that was like a lot to take in, but I want to end this by giving out this advice that you focus on your fundamentals. And there is nothing better to focus than this book, the CLRS book, right? Which is sort of like the fundamental things that all of you should be reading. And if time permits, even this, right? I cannot stress enough that knowing cloud will not land you a job. Knowing the data structures and algorithms with how it's actually implemented and some idea of cloud and the technology will help you progress, right? Even to this day, I practice my algorithms, right? Because it's fundamentally that. I know I've talked about cloud, I do cloud work in an area, but at the end of the day, I have to program. And that programming thing comes with the solid foundation that you actually have to build. And my favorite book is one of this, one of the algorithms, or go to one of your competitive portals or whatever, and then build your system design concepts, build your algorithms, think about design patterns, think about how the object oriented approach is basically work, build your oops concept. And I'm not saying whether it's like C++ or other languages like Java or something, build your oops concept, right? Of what abstraction and everything, right? And the cloud and everything is magically just come over, right? Because this is the number one takeaway that I want to give, and that is you have to build your fundamentals and the rest will actually follow. So that's sort of like the career advice that I actually wanted to give. And with that, I think, yeah, we're just about on time. And with that, I'll just stop sharing and probably, maybe take a few questions as well.
Hello, sir. Thank you for that. Thank you for your kind words. They were really informative. We learned quite a lot about the cloud.
Sure.
Yeah.
Are there any
So,
questions? Then I can engage take.
yeah, sure. So, audience, if you have any questions, you can drop them in the comments. Let's dive right in. We've got a question. How do you explain serverless to a layman?
Serverless to a layman, that's like a very important case. Like how do you explain cashless, right? So I gave you that analogy that serverless doesn't mean there are no servers, right? It's just less servers. So just like cashless doesn't mean that there is no cash. It's just less cash that is just floating around. So there are less servers floating around. So you manage less servers, you focus more on the business logic of attaining it, and the whole infrastructure of building it up and scaling up and scaling down and everything, that is completely abstracted away and just use the API endpoint to actually do that. So that exactly is the serverless paradigm.
Thank you, sir. On that note, Akash has got a question. What do you think is the next
Hmm.
layer of abstraction after serverless?
I don't know, man. That's Akash. I have no questions. When I started my career, right? Maybe like when I started my career, I did not know that I would have been talking about serverless and computing like 15 years later, right? If you had asked me this question like in 2004 or 2005 as to what the cloud was and what this thing is when I started my career, I would have given up, right? The world is changing so fast. I don't know what abstraction is going to be. I don't know what the new stack is going to be like probably 6 months later. But the stack keeps coming. I am saying don't chase the shiny objects, chase the ones that have been proven. And that is why I say that you have to focus on your fundamentals. your concepts. If you get your stuff, it doesn't matter what comes after serverless. Who cares? You know your fundamental building blocks on terms of compute, storage, networking, and how it all comes together in code in terms of linking it all together, right? So we should not be scared of technology, because if you know your building blocks, your foundation is correct. I am not scared. My first programming assignment in my first job at Infosys was on a mainframe, and all my whole college days, I have never seen a whole mainframe before. But I did that programming, and now I'm in programming in Golang. If you had asked me what was Golang way back then, I wouldn't even know. So yeah, just don't worry about that.
Thank you, sir. Meet has a question.
Okay.
Yeah.
So what is a cloud enthusiast, cloud architect
So,
aspirant looking
what
for
should
a
a
change?
cloud
Should he
enthusiast
focus?
look towards?
Yeah. Should he focus on the professional cloud exam, or should he get his hands more and more dirty on the maximum cloud services? So the question is mostly from a cloud architect, and I'm assuming that this person is the potential person whom we are talking about, an aspiring cloud architect, is not a novice person. He is experienced, and he's been working in the technology sector for some time. So if that's sort of like a thing that you want to aspire or do like career shift after a few years of experience, then yes, definitely the exam definitely works. But having that knowledge by, as I said earlier, right, answering a multiple choice questions by learning sort of like the brain dumps and everything, it's very easy. And having a lot of certifications will help you land that interview. But in the interview, they are gonna rip you apart. So having a certifications doesn't necessarily mean that you get the job, you get the interview. But having a certifications without the basic understanding of what these services are or what it actually does, or without real hands-on customer architecture, it's definitely a different ballgame. So if you have your right amount of skill sets with the right experience, then the certifications is not it's sort of like a supplement. It's not a means to an end. It's a supplement to your existing skill set. It's a validation of your skills. So yeah, that's what I can say for.
Oh, thank you, sir. Another question we have is Anirudh's asking, what is a service mesh?
Yeah, that's sort of like a 201 topic, or maybe like even a 301 topic. I can cover it, but service mesh is nothing but we've talked about the microservices that attained with terms of containers or serverless, and each of these microservices would have to actually talk to each other, and then it becomes sort of like a big tangled mess or a mesh, so to speak, right? And you need like a service to actually manage it. And then there are like things like Istio and other things that actually helps you orchestrate these services in a much better harmony instead of you doing it yourself. So that's the service mesh. But I don't want to deep dive into it. It's this is a 101 session.
All right. A question I had from my side was, you mentioned the Cloud Native Computing Foundation. What exactly does that foundation do?
Yeah, so that's sort of like it's similar to the IETF or the Internet Engineering Task Force, right? That is there, or the W3C consortium for the web, right? So the CNCF framework is the umbrella organization, or sort of like from the Linux Foundation. So it's sort of like a sister of the Linux Foundation, which helps you create this standard for the various services that are there. So it helps you establish the the main defining or the working standard for the various cloud services. So just like the various standards that we have, like for C++, right? C++20 or C++17 or whatever, right? Or the ASCII values that we had in the beginning. So the CNCF is basically something that was there, that is there for the cloud thing. Instead of everyone going in multiple directions with their own implementation, let's have like a common implementation of the various important projects that helps you define the stuff instead of relying on a vendor specific. So you can have those offerings from the CNCF instead of tying to a specific vendor. So that's the whole idea of the CNCF.
Sounds very interesting, sir. And I think last question from my side would be, so most of our audience here are students and we're all just
Okay.
beginning to get into cloud. And we all love learning by examples. So could you give us maybe an example of how students have used the cloud in a way that just wasn't possible before?
Students, yeah, I mean, look at the case of Oyo, Ritesh Agarwal, right? He's just 26 years. He started Oyo in his student days by using cloud. So yeah, so that's the thing. That's the possibility of doing stuff with cloud. You can build your own startups. You can, if you have attended hackathons, right? I've seen many students using cloud in n number of ways, right? Because instead of building your own complex models for the cloud, right? You can use a managed services that are there in terms of vision or cloud text to speech or natural language processing and all the other things, right? So instead of doing that whole grunt work that you used to do earlier, now it's all there as a ready to use consumable service, and you just focus on building your application logic. So if you have this next $1 billion idea, you don't have to worry about procuring servers. You don't have to worry about how I manage these whole infrastructure. You wouldn't have to worry about how am I going to build this whole uh, complex data logic that needs to be there. It's all there in a ready to consume, and you can just focus on your stuff that is there. So yeah.
That sounds very interesting, sir. Lots of opportunities for our students to look forward to.
Yes, definitely.
Karthik, would you like to take over?
Yeah, sure. Thank you, Susan. I think this was the last question. So thank you very much, sir. It was great having you with us here at TSC Pursuit. And we look forward to having more sessions with GDG later. If we get any further questions, I forward them to you and we can get them answered.
Sure, sure. Yeah, I'm always reachable on my social media handles. Anything, you can just DM me, and I also post the slides and everything on my Twitter handle as well. So feel free to check it out all. All right. Yeah, pleasure talking to you guys.
Sure. Thank you. Thank you so much.
Yeah. Thank you. Bye bye.
Thank you, sir.